Okay, so we are starting our new topic. We are not leaving the old topic. Your entire test, guys, was like 6 different ways to tell you to set it equal to 0 factor and solve. That's every single problem, except for the long division, synthetic division. So that was it. So we are not leaving factoring behind. It's going to come up again. So if you are still struggling with factoring, which some of you are, you need to come see me because we are done. I'm done teaching it to you. Does that make sense? I've taught you how to factor. Now you need to practice it so you can do it. Because could I tell you how to factor every single factoring problem there is out there? No. I can tell you what to do, the procedure, right? I've taught you the procedure. I've taught you several different procedures that you could use, and you just have to practice it so you can look at a problem and do it, okay? So we are going to still use it. It will probably be on every single test from here to the end, just like every single test you have a fraction show up that you have to deal with. That's what's going to happen with factoring, okay? You're going to have factoring come up. You're going to have to use it. I was doing a geometry lesson, the notes the other day, and they are factoring in geometry. So it's something that you have to do, okay? So for one, inverse variation and the reciprocal function. Today we are only going to deal with inverse variation, and tomorrow we are only going to, well, not only because it's not isolated, but we're going to deal with the reciprocal function. So an inverse variation is a relation between two variables such that as one variable increases, the other variable decreases proportionally. So if you look at my one set here, x's are increasing and y's are decreasing. Could it be the other way around? Yes. Okay. But one variable is increasing where the other one is decreasing, and that's inverse variation. For two variables to represent an inverse variation, the product of x and y must be constant. What does product mean to do? Multiply. So I, on this slide, have added the x times y row, but on the next slide I didn't. So all you have to do is add it. That's it. Okay, so what is 1 times 12?
12.
12. 2.
12.
How about I get a pen and not an eraser? Okay, so I get what all the way across?
12.
12. So does this show an inverse variation?
Yes.
Like it. Okay, so this is an inverse variation.
The next one is not.
Okay. The next one, I get what?
20.
20.
Then 34. 32. No.
42.
42. 44. 45. And then 30.
40.
No. Oh, crap. I was thinking 9.
You guys know that an even number times an odd number will always be even.
Okay, but you got Evan back there.
Hey,
Just checking. Okay, so the one on the left is an inverse variation because their product is constant, yes?
Yes.
The one on the left, is it constant?
No.
No. It's not. Doesn't mean it's not a function. It doesn't mean it's not a relation. It just means it's not a what? Inverse variation.
Do I need to write those boxes down?
That's up to you. You'll have the next two examples. Like the next two, I'm going to make you do, so.
Is that another snow slide? I saw one earlier.
In here?
Like right at the beginning of class.
Oh, then I was like, that's the first one I've seen out there. So, and I wasn't in here, so. Okay, am I good?
Yeah.
A chunk just came off the snow. Okay, so here are two. I want you to tell me if they're inverse, they model an inverse variation or not. Now, to be an inverse variation, it has to be true all the time, right?
Yes.
To not, it only has to be false how many? Once. But if you get one that's not the same, you probably should check another just to check. Because sometimes we can't multiply, right, Evan?
Yeah.
And if all of them are coming out the same except for one of them, you might want to second check that one.
I already know that.
Well, you need, as long as you have an example in your notes. I'm tired of people saying their notes aren't doing them any good.
I see it.
If we're going to take notes, they need to be valuable to us in some sort of way and not firewood.
Firewood pretty good.
Well, paper ain't going to last you long, so
Actually can start a fire.
yeah, but it ain't going to keep you warm.
Not with that attitude.
First thing day after tomorrow, those books go real quick. Okay, do you have the first one and part of the second one done? Part of the second one? Okay, you do? Okay, so what's the first one? Is it?
Yeah.
Yeah, what is it?
25?
25.5. The one that threw you off was 17 times 15, right?
Yeah.
You actually had to do it out.
Yeah.
And when you're like, that ain't gonna be 25.5, and then it is. Okay, what's happening on the second one though?
It's not.
It's not. Because that
19.8, right?
and that already doesn't match.
And this
that
is
one.
27.5. And I already should know it's a no unless I can't multiply or I messed up, right? So I need to check another one. So this is a 30.8. Yeah, so we're not there, are we?
No.
Okay, so the second one is not. The first one is an inverse variation model, and the second one is not. Longest part it took was to write down the problem, wasn't it?
Yeah.
I've showed you guys multiplying by 11, haven't I? Separate them, add,
Yeah.
Maybe.
Okay.
Have
use
you?
it. Okay,
Remember
so
it.
22 times 11, separate them, add.
Oh.
13 times 11, separate them, add. Every time.
That's crazy.
So 89 times 11. 8, 9, 7, 1, 70, 9, 79.
Smart man. Smart man.
Okay, works with any two digit. Okay,
Okay.
But it don't on 3 digit?
3, there's a different rule that's more complicated than just to multiply by 11. Because when you multiply by 11, you're just multiplying by 1 and moving it over one place anyway. Okay, so when a relation between x and y is an inverse variation, we say that x varies inversely to y. X varies inversely as y. That should be 2y. I think it's 2.
Okay.
Let me make sure. The book may think it's one thing. I would say x versus inversely to y. But we'll see what they say. They're probably, I don't know, just smart as me. And then we had x times y. We were getting a number, right? We got 25.5 and we got 12, right?
Yeah.
So you can solve that for different things. I'm really wanting to get this before I go on. Sorry. It's bugging me, whether it's to or as. We're going to put money on it, guys.
No.
I don't
$20.
bucks anymore.
$2.
I think it's 2.
Did you just copy this from the book?
They say as. Yep, I say to, but they say as. I don't think it really matters, does it?
Probably not.
It varies inversely. Okay, so I gave you this, right? We basically did that. We did x times y, and we came up with the same constant number, right? That's called the constant of variation, is what we came up with. But I'm going to tell you right now, down the ACT, there's at least one, if not two questions that says that this varies inversely to this. And write an equation. Well, we don't write equations x times y equals k, do we? It's y equals usually. So if I had x times y equals k, to solve for y, I would divide by k, or x, right? So when it's looking for an equation, it's y equals k over x. And k is that constant of variation. Okay? So do all three of these things say exactly the same math?
Yeah.
Yeah. But we tend to write equations y equals. No.
No.
So when it asks you the question on ACT, it may say like which equation models x varies inversely to y. I don't know, I'm trying to make up something that who knows what it says. And that's going to have it in this form. Or if it's choose all that apply, could they give you all three? Yes. And we know enough algebra that we should be able to move things around and figure out if they're all equal to each other, correct? Okay. So when it asks us for an equation, we will be using this right here. When it asks for an equation. But when it asks us if they are inversely related, then we'll be using the x times y because they'll already give me x and y, correct? So still same equation, pick which one you want to keep in your head. I will tell you if you're only going to keep one, I would keep the y equals k over x. Got it?
Okay.
Because that's the most commonly used for a function, like just an equation. So what is k?
K is the constant variation.
Okay, and we need to know that because it will say, what is the constant of variation? If you don't know what that is, you're gonna look at me at the test going, huh? And how did we find K? You took X times Y, correct?
Yeah.
Or if you plugged it into Y equals K over X, you would still multiply both sides by X because that's how you would solve for K, isn't it?
Mhm.
Okay. Everyone good with this slide? No one's yelling and screaming. Okay, an inverse variation, so it says it's inverse, so I already know the equation. What's the equation? Y equals what?
Y equals 3. Well,
K.
K over X. Okay, so Y equals K over X. X is 10, Y is 3. Write an equation that represents the inverse variation. So equations have X's and Y's in them, don't they? So what do I need to solve for? They gave me an X, they gave me a Y, I need to solve for K. So how do I do that?
10
You
times.
take X times Y.
Or first I do what?
Put it in, you know.
I plug it in the equation, right?
Yeah.
Yeah. So it's 3 equals K over 10. And then to solve for K, I'd multiply by 10, right?
Yeah.
So K equals 30. So my, what is that called again?
Constant
Constant of variation.
Constant of variation is 30. So how do I write an equation?
Okay, Y, no, 3 equals
No. Equations have what in them?
Y.
And
X.
X. So what do I need to plug in? Only thing I need to plug in.
30.
K. So if I Y equals 30 over X, isn't that an equation? Yeah, because it's Y is the output, correct? And X is the input, and the input can change, right?
Yep.
So that's the equation. So that's part of my answer. Now what else?
Now you will plug in -6 for X to find the value of Y.
Now we're going to plug in -6 for X and solve the value for Y. Have we done that over and over and over and over? So Y equals 30 over -6. So Y equals
-5.
-5. I'm going to tell you that this is a question that on the ACT, kids coming back to me and go, I don't remember how to do this. They had this inversely thing. Guys, it's Y equals K over X. Every time.
I'll probably forget it.
Probably. But I'm just telling you. I taught you. Okay, so an inverse variation. So once I see that, what should I be thinking? Y equals K over X. Every time. Because there's 3 variables there, yes? Y, K, and X. Could I give you any of the 2 and you could find the other one?
Yeah.
Just by moving it around, right? So Y equals K over X, and if you write it the whole 2 times you have to do it today, it might stick a little bit. Okay, so X is 6, Y is a half, so find me my K. I'll ask you, but everybody else has to have a chance to do it.
And then do you want to put machine in for X?
Sure.
I solved it all the way.
You got it. Do the whole problem. Bunch of smarty pants as you is. So how long are your 5 problems going to take you today?
10 seconds?
Well, I don't know, probably like 3 hours.
Probably.
Probably.
4.
Depends on how many fractions you give us.
Well,
Fractions aren't
it's,
even
I gave it
that hard
22.
fractions are not that hard.
when you're dividing.
Whenever it's still Saturday.
Well, dividing isn't either. You just multiply by those.
So if you give us a
Twelve
fraction
o'clock,
and
so.
either K
Okay,
or
so what is
X.
K?
K
3.
is 30.
3. I have 1/2 of K over 6. Multiply both sides by 6, and I get
33.
3. So what is my equation?
Y equals 3 over X.
Okay, and then Y equals 3 over 15. So Y is
Y is 1/15.
1/5. What if this was y and this was x?
Multiply by reciprocal, right?
Multiply by reciprocal. So you would have 6 equals k over 1/2. So what's the reciprocal of a half? 2. So what's k? 12. Okay? Fractions are not that hard, guys. You need to remember the rules. When you divide fractions, you're really just multiplying by the what? Reciprocal of the second one, right? Not the first. When you multiply fractions, what do? How do you do that? Numerator times numerator, denominator times denominator. What should I always do before I multiply though?
With the-
No. I don't know what flipping is, but don't do it. I do know what it is. It's reciprocating. So use the word. I should always reduce before I multiply. Why?
So that you.
Because you have easier numbers.
Smaller numbers. Because if you do the multiplication, you're left with these huge numbers, and your brain leaves the building when you have to simplify, don't you?
No.
Okay. And I can reduce which ways? Can I reduce diagonally or
Up and
up
down.
and down?
Oh, yeah.
Can I do side to side?
No.
Always, 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 always reduce before you multiply. It would make your life much, 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 much easier. And if you know you're going to have to reduce, but you multiply first, guess what I never do? Multiply, just write it and then I reduce. I'll show you that one later. Okay, questions?
No.
Nope, that's it. That's all I got for you.
Okay, man, this room.
Yes, you may.
Is that our homework assignment?
Yes, your homework assignment is on the board or it is online. Either one, but it is